This was kind of last year's bang. As a real carnivore, I'm pleased to say that there was a differently kind of bang in Germany this year. And I'm very, very glad that we found one of the experts who recently moved from Germany to the Netherlands, Alexander Friedrich, who's now at the University of Groningen, to talk about AHEC made in Germany. And for all those who are getting a little bit sweaty in here, and it takes long, I can promise you these are now two very, very, very fast speakers. So if they're the ones that still have to follow. If they weren't yet, they will be now. Thank you very much, Alex.
Thank you very much, Andreas. Thank you very much for inviting me. I'm supposed to do that in 4 minutes. But I think the topic deserves some more minutes. I'm very happy to present you that the details on the latest developments. I moved last year from the National Reference Laboratory for HUS in Germany to the Netherlands, and we are working cross-border also in this topic here. So EHEC made in Germany, I put a question mark, threat and EPEC. We had the focus on India. Let's have a focus on Europe and what we are able to do. And after 12 years of fundamental research on EHEC, you see on Google Trends why I was so sad the last years. Nobody was really interested in EHEC. And you see the peak in March 2011. And it's interesting that there are the cities in Oldenburg and Hamburg and Bremen that are looking to the topic of EHEC. And it is exactly what was published. It was first published, but also published in New England Journal of Medicine from the group of Gerard Krause about the epidemiology, the epicenter here in the north and all of Europe and other countries outside. It was a peak, and 2 days before the public was informed was the peak of the outbreak, and more than 3,000 cases, incredible number of HUS cases, and I've never seen in 12 years of research on HUS, and more than 40 patients died. It is an E. coli. EHEC, how we go about that. I have seen that E. coli about 10 years ago, together with Helge Kach in Münster, from 2 siblings, 104H4. They were in Cologne, and they had an HUS, and they're both infected. But it was this time. It was another description from Korea, from a 29-year-old woman with an HUS. But the ESTEC or the EHEC, they are pathogenic diarrhea causing, bloody diarrhea causing, and especially the HUS. Most frequent cause for acute renal failure, infectious sources, large outbreaks known. There's no specific therapy, there's no specific prevention. There are experimental forms, but no really therapy. This was in 2000 via surface water after a thunderstorm. The chlorine system was not working, and so over the water, into the water came that. And at that time, Bill Clinton was not as important, as you see here, than the killer germ on the front page here. This is the toxin cocktail of an EHEC. And EHECs are E. coli, and they are usually something else. They are enteropathogenic E. coli, or they are other E. coli, and they gather during evolution other virulence factors. And this is what you see here, EHEC 0157, the classical one. He has a lot of several virulence factors, and also the Zika toxin, but not only. And if you look at the 004 EHEC infection, everybody of you who knows the HUS sees that it's quite different. Not 3 days of incubation period, but 8 days. Most of them bloody diarrhea, and then 5 days instead of 7 days till the HUS comes, and then 20 to 25% developed, looking at the data of the colleague Frank of the Robert Koch Institute, and HUS that usually are lower than 15%. If you look at the pathogenesis, it shows that things are different to what we knew till now. So the story has to be rewritten. There is no attaching and effacement, but there's a sticking of these bacteria on the gut, in the colon, And then it is usually known that the Shiga toxin is going into the body, not the bacteria, usually is found in the early phase. And then, like a Trojan horse, it is transported to the endothelial cells of the glomerula in the kidneys or of the brain artery. And there you get the typical subendothelial problem with the glomerular thrombotic microangiopathy. What is different than before? In 10 years, I saw 812 patients. And within 1 month, the same amount of patients was seen in this outbreak. They were usually children, and now they're adults with about 50 years old, between 22 and 87, and they're especially women. It is not the usual clone. It is also not the incubation period we know. It's 8 days, more bloody diarrhea, more neurological symptoms, and more HUS. And what remains true is that the Shiga toxin subtype, the dangerous one, remains the dangerous one. The Shiga toxin remains a good predictor for the severity of disease. This EHEC 004 USEC 41 has the classical STX2A. It is not the Shigella-associated STX1. It is not the environmental-associated STX subtypes. This is the STX classical one that is associated with HUS. Is it a new strain? It is known. It has been published before. It is a USEC 41, first identified also in Germany in 2 siblings. It is known where it is found. It is close by the HUS classical O serogroups, but it is another serogroup. It is sorbitol fermenting. You cannot find it if you look only to sorbitol McConkey. It is Telluride resistant. It is not really a new strain. It is mostly similar to the reference strain USEC 41, published in Lancet Infectious Disease a few days ago by the group of Helvekaj and colleagues. It is 92% in EAEC, an enteroaggregative E. coli. And he has typical EAEC loci, and he has typical Shiga toxin producing E. coli of EHEC loci. What is really new is the ESBL resistance pattern of a CTXM. And he is missing the yeast toxin, and he has another fimbria. He has no ETEC, no EPEC, and no enteroinvasive typical loci. So this has happened some times ago. It is not new, but what is new is the resistance pattern, and there is an in vivo evolution. So the outbreak scenario, to come to an end, there is a reservoir. We have the primary source, we believe. It's a fenugreek seed. From there, it comes the outbreak source. It's come to human. And since then, after the huge outbreaks, thousands of people that have been exposed, surely then we have secondary sources, a lot of secondary sources within families or within these settings. But we have no idea really where the reservoir is. Is it on fruits and vegetables? We know that since the 90s has been published on sprout seeds, on others. You can find that, and E. coli can survive more than 1 year in the environment. Be careful, because bacteriophages, converting bacteriophages with Shiga toxin are found in the environment. If you perform a PCR on something that is from the environment, it might be positive. This time it is innocent. But also the cucumbers had their revenge here, and they were higher than the EHEC. From point source to human, there was a major point source, fenugreek. But where does the seed come from? Nobody knows. It is the same strain that now in France is the origin of the outbreak of 6 women and 7 HUS cases, 10 altogether. And they say the seed comes from UK, but it is the same E. coli, it's the same USEC 41. I am sure they are related, and the seed must come from somewhere, common source. 3 children in the school of northwestern Germany have been 2 had an HUS. It was the cook and 2 persons in the kitchen, so secondary transmission, the school has been closed. And the sentinel of bloody diarrhea is still higher in the region where it was. Last 3 slides. It is again, after more than 100 years, in Hamburg and the region around, where an epidemic of dysentery occurs, and where Robert Koch said, everything depends on the fact that we have valid detection methods for the microorganisms, and this counts especially for the human carriers who contribute most for the spread of disease. Let's see if that is true. 004H4 is a new chapter. It is an old known, not friend, but he's an old known, and there is a comeback. He has an enhanced pathogenicity, Why adults? Why women instead of children? The high clinical manifestation index might be explained, as done by the group of Helge Kaas, by a low antibody prevalence in the population for the LPS 0104. The newly acquired resistance is a problem because it's the first time that ESBL resistance is now found in the obligatory pathogenic microorganism with no specific therapy. That's different than what we had till now of facultative pathogenic microorganisms. That is the nightmare I was dreaming of the last years, and we are living that without that we get into panic, but we have to see it as a new chapter in the evolution of this microorganism. CTXM15 is known in humans, so where's the reservoir? It has a different epidemiology, a long incubation period. Enteraggregative E. coli are known for their human reservoir. It is a diurenic pathogen with severe complications, and we see asymptomatic carriers that can infect others. Although it is not very easy, but it is happening. I think, and I would like to conclude with, we have to act. We have to find the reservoir. Our food and water must be safe. Personal hygiene is crucial. Diarrhea cannot be considered as normal. You cannot have diarrhea and go just to work and doing business as usual. That's one of the major problems we are facing at the moment, not only in Germany, also in the Netherlands and other countries. Those who call for a central coordinated action in Germany should immediately call for a central coordinated action in Europe, of course, and then say, no, there everybody does it on its own. We need a central coordination in Europe, of course. This is not a German problem, this is a European problem. Focus on communication and early detection. Things came some too late. But Germany, and I tell you, I know that, has done maximum effort. Nobody would have been really prepared to this new chapter. And I ask you, are we all prepared that we are sitting here? I believe all the veterinary and human medicine, they must work together in the One Health preparation. We need international basic and applied research for that. We really don't know enough. And we have to foster, after 120 years, what our ancestors said, foster preventive microbiology and infection protection. Thank you very much.